Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Today we delve into the core of one of the great controversies in solar physics. In the 1960s, scientists first discovered that the number of solar neutrinos detected on Earth did not fit the predictions of the standard model of the Sun. In this model, the Sun is powered at its core by a thermonuclear reaction, and the production of neutrinos occurs in the Sun's interior. In more recent years, scientists have adjusted some of their ideas about neutrinos, and news headlines have pronounced that the mystery has been resolved. But should the neutrino problem really be laid to rest? To explore this question, we asked Wal Thornhill for an overview of neutrino production in the electric sun model.
It's been said that the electric universe model predicts that there will be no neutrinos from the Sun. Well, that's obviously incorrect because the electric universe model was produced long after it was known that the Sun produces neutrinos. The problem for the standard model of how the Sun works is that the number of neutrinos detected was always about a third of that calculated. And this, in effect, was disproving the idea that the Sun's energy was generated in the way originally suggested by Eddington back in the 1920s. The point is that the standard model of the Sun is almost 100 years old. It was born in the horse and buggy and gaslight era, if you like. And at that time, the problem was that it was not understood how the Sun could have kept shining for the geological ages that were being discovered, because the age of the Earth was being progressively pushed out from hundreds of thousands to millions and then to billions of years. And the question was, it seemed obvious that the Sun must have shone for most of that time. And then the question arose, how do you power the shining Sun? So when nuclear energy was discovered, it was immediately grasped because it offered one possible way of producing the energy for the time span required, billions of years, since it consumes so little fuel in any given moment. The problem then was to explain the Sun in terms of a nuclear reactor. And of course, the scientists came up with a very ingenious scheme, which required that the Sun be composed entirely of hydrogen, which defies all common sense when you think about it, because heavy elements will sink to the center of an object, and the hydrogen would sit as an atmosphere. Anyway, disregarding that, it was assumed, therefore, that all stars were born shortly after the universe was created, and that at that time, most matter was in the form of hydrogen and some helium. Now, the problem with the nuclear reaction theory is that it is an extremely unstable and very complicated process. Producing nuclear fusion by squeezing and heating matter in the center of a star is the most inefficient method conceivable, as witnessed the half-century or more long attempts to produce fusion power in laboratories on Earth. It is a highly improbable process even under the calculated extreme conditions at the center of the Sun. The unlikely process omits to mention that quantum tunneling is also needed to make it work. And if nuclear fusion is happening as theorized, it can only produce the first few light elements in the periodic table. So the question is, where do the heavy elements seen in the Sun's spectrum come from? Well, the answer is that it's a kind of impurity from supernova explosions. But there are far too few supernova explosions to have produced the heavy elements observed. And what's more, a supernova is in the business of exploding and dispersing matter into the vastness of interstellar space. It's much better to have a theory that solves this fundamental problem in place, inside or on stars. Nature doesn't do anything the hard way, so why would she not use the same technique that particle physicists use to create heavy elements on Earth? That is, particle accelerators. But particle accelerators require electrical power, and astrophysics is the only science that doesn't use it. Astronomy remains, with Eddington, in the gaslight era. The detection of neutrinos has been only about 1/3 of the calculated number, and the discrepancy is well outside both the uncertainty of the calculations and the experimental deviations. The problem was so intractable for the Standard Model and astrophysicists that particle physicists were called upon to determine if there was something we didn't know about the neutrino. So the particle physicists proposed that if neutrinos had mass, which at that time had been undetected, they might oscillate between the three known forms, the electron, muon, and tau neutrinos. The low count of electron neutrinos might then be accounted for if they had changed flavour, as it's called, on their journey from the Sun's core to the Earth. This is because the neutrinos can pass through the matter of the Sun without being interfered with. In 2001, it was announced in Physics World that the solar neutrino puzzle is solved, and I quote, "The first results from the Sudbury Neutrino Observatory in Canada have finally solved a problem that has puzzled astrophysicists for 30 years. Why do experiments detect less than half the number of solar neutrinos predicted by models of the Sun? The results confirm that electron neutrinos produced by nuclear reactions inside the Sun oscillate or change flavour on their journey to Earth. Neutrino oscillations are only possible if the three flavours of neutrino, electron, muon, and tau neutrino, have mass. The Sudbury result therefore has important implications for both cosmology and particle physics." So what are neutrinos? Well, neutrinos are elementary particles of matter with no electric charge and very little mass. They only interact weakly with matter, which makes them very difficult to detect. Indeed, the Sudbury experiment detects a mere 10 or so neutrinos per day. Electron neutrinos are produced in the Sun's core when boron-8 nuclei undergo beta decay, and the Sun is not thought to produce muon or tau neutrinos. Previous experiments have detected less than half of the predicted solar neutrino flux, but these experiments were only sensitive to electron neutrinos. Now the combined Sudbury and Super Kamiokande results make it clear that this shortfall arises because electron neutrinos have changed into muon or tau neutrinos. This result agrees perfectly with theoretical predictions and indicates that we really do understand the nuclear processes that are the source of the Sun's energy, said Lincoln Wolfenstein, a particle theorist at Carnegie Mellon University in the US. By comparing the figures, physicists from Sudbury and Super Kamiokande calculated that true solar neutrino flux is 5.44 million neutrinos per square centimetre per second, which is in excellent agreement with the standard solar model of energy production in the Sun. But this headline underscores a cultural problem in reporting science that leads to bald statements of fact when a conclusion is in fact conjectural. The detection of neutrino oscillations cannot confirm the standard solar model. It merely offers a possible solution to one of a number of serious observational problems with the standard model. There can be no confirmation of oscillation of neutrino flavours between the Sun and Earth without simultaneous neutrino measurements being made near the Sun, and that poses formidable experimental problems. On the other hand, the electric universe proposes an electrical model for stars based on the pioneering work of the engineer Ralph Jurgens. So the question is, what if the neutrino discovery is correct? And it seems to be so. It says nothing about the correctness of the standard solar model, but it does have important implications for cosmology and particle physics. If neutrinos do have mass, it will confirm the electric universe model. The electric sun model expects far more complex heavy element synthesis to take place in the natural particle accelerators in the photospheric lightning discharges. That is, the light of the Sun is electrical, and it's of such a power that can actually generate nuclear fusion reactions. But the nuclear fusion reactions are not restricted to those that were planned or worked upon back in the 1920s. In this case, the various neutrino flavours are all generated on the Sun and do not need to oscillate on their way to the Earth to make up an imagined deficit. What is more, fluctuations in neutrino counts are expected in this model to be correlated with electrical input to the Sun, that is, with sunspot numbers and solar wind activity, and this has been observed. The standard solar model does not expect any correlation since there is a lag estimated in the hundreds of thousands or millions of years between the nuclear reaction in the core and its final expression at the surface of the Sun.
On the question of the very nature of the Sun, a critical issue rarely discussed in popular media is the recent discovery of anomalously weak solar convection, between 1 and 5% of what the standard model requires.
It has to be acknowledged that recent research has shown that the so-called convection beneath the photosphere, which is supposed to drive all of the magnetic phenomena that we see, including sunspots, just isn't there. It's only a fraction of what is required by theory. So the sunspots themselves are not explained in the standard solar model. To sum up, the electrical model of the sun requires that neutrinos of all flavors are produced by heavy elements nucleosynthesis in the photosphere of the sun, right where we see it. It is far simpler than the nuclear fusion model, whose major assumptions cannot be confirmed either by visual inspection or certain rogue data. All of the obvious electric discharge phenomena seen on and above the photosphere have analogues that can be seen on Earth or reproduced in electrical engineering laboratories. It is far simpler to assume that the energy received from the sun is coming from where we see it, at the surface or photosphere, rather than a minuscule and unlikely hydrogen bomb 93 million miles distant, shrouded in opaque gas. Then the very fact that sunspots are dark makes perfect sense. It is cooler everywhere beneath the photosphere. Mysteriously generated magnetic fields are not required to explain every strange solar phenomenon and to defy the laws of physics in the process by breaking and reconnecting hypothetical field lines. The surprisingly even magnetic field of the sun from the equator to the poles is to be expected if the sun is the focus of a cosmic electric discharge, as Jurgens first suggested 30 years ago.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Today we delve into the core of one of the great controversies in solar physics. In the 1960s, scientists first discovered the electric sun model.
It's been said that the electric universe model predicts that there will be no neutrinos from the sun. Well, that's obviously incorrect because the electric universe model was produced long after it was known that the sun produces neutrinos.
That the number of solar neutrinos detected on Earth did not fit the predictions of the standard model of the sun. In this model, the sun is powered at its core by a thermonuclear reaction, and the production of neutrinos occurs in the sun's interior. In more recent years,
the problem for the standard model of how the sun works is that the number of neutrinos detected was always about a third of that calculated. And this, in effect, was disproving the...
Scientists have adjusted some of their ideas about neutrinos, and news headlines have pronounced that the mystery has been resolved. But should the neutrino problem really be laid to rest? To explore this question, we asked Wal Thornhill for an overview of neutrino production in the